Good morning to you all students. Hi students, how are you? I hope you all are fine. So, have you all revised yesterday's portion? So, till now we have completed chapter 1. So, I have marked question answers for chapter 1. So, have you all studied from question answers from chapter 1? So, what are the important questions I said? So, whether you have studied all the important questions from chapter 1? Please don't study important questions alone. All the things you need to study. Okay, so now we are studying chapter 3, isn't it? So before I am going to start today's portion, so I am giving one assignment or homework for you from chapter 1. Okay, so listen carefully. What's assignment means? So first chapter, types of generations of a computer and functional components of a computer and types of printers. That means impact and non-impact printers. Okay, what are the things? Types of generations of a computer, then functional components of a computer, then types of printers. These three questions you should write in a separate paper and you should keep with you. This is the assignment for the first chapter. Whenever the school opens, I will ask for this one. Okay, so please don't ignore it. Write assignment for the chapter 1. These three questions you should study and write. Don't see and write, study and write. Okay, so shall we move to today's portion? So welcome to today's online class. Today we are going to study about the chapter 3, computer organization. So already we have thought about this. I have taught this computer organization, isn't it? So just I have give the introduction. So this chapter mainly we are studying about what? Hardware and hardware component, that means internal components of the computer or internal components inside the CPU, isn't it? So mainly last class I have taught about microprocessor. So which is the major component inside the CPU to perform the task? Microprocessor, isn't it? Yes. Then this block diagram I have explained. Up to this I have completed, isn't it? Microprocessor made up of 3 main units. What are the units? Arithmetic logic unit, control unit and registers. Today we are going to study about characteristics of microprocessor. So this microprocessor depends on mainly 3 characteristics. How many characteristics? 3. What are they? Clock speed, instruction set and word size. What are the 3 characteristics? Clock speed, instruction set and word size. Okay, so I have explained about first thing, clock speed. What do you mean by clock? What's the use of clock actually? What's the use of clock? We used to see time in the clock, isn't it? Likewise, so every microprocessor has an internal clock. Okay, so while designing itself, every microprocessor has an internal clock. Okay, what's the use of that clock? What's the use of microprocessor? It will execute the instructions. So what are the instructions given to the CPU? That means what are the instructions we are given to the computer? So it will take the instructions and it will execute. That means processing. That process only we are calling as an what? Processing. So what's the use of this internal clock means? So it will regulate the speed. At what speed the particular instruction need to execute. Understand? What's the use of this internal clock? So it will regulate at what speed whatever instructions we are giving, at what speed particular instructions need to execute. Okay, so in which speed particular instruction is executing, for that the microprocessor at what speed inside the microprocessor, at the what speed the particular instruction is executing, that speed we are calling as an which speed? Clock speed. Okay, so a microprocessor execute the particular information or instruction at what speed it will execute, that speed we are calling as in which speed? Clock speed. Understand? Important 2 more question. What do you mean by clock speed? Then this clock speed is measured in 2 units. What are the units means? Megahertz and gigahertz. Okay, so clock speed is measured in how many units? 2 units, either in megahertz or in gigahertz. Understand? This is the first characteristics of microprocessor. Next we are going to see about second characteristics called instruction set. Okay, What do you mean by instructions? So each and every places you can see, if you are going somewhere in tourism places or any important places, anywhere, hospitals or anything, they will give some instructions. What do you mean by instructions? Commands, isn't it? So these are the rules are rules. Otherwise we need to call as rules. So these are the rules you need to follow. That only we are calling as an what? Instruction. So instruction set. So by name itself we can identify set of instructions we are giving to whom? Set of instruction we are giving to whom? Computer to perform the task. So that instruction is carried by whom? Now we are studying about whom? Microprocessor. Which component? Microprocessor. Understand? So we are giving all the input by means of instructions of command. Okay. What's the use of this command? What's say for example? So particular place a traffic will be happening. Okay. So a traffic police is there. Traffic police will give some command. Go right, go left, take right, take left, go straight. So based on his command, particular person will move his vehicle based on that command. Isn't it? So who is giving command there? Traffic police. Likewise, the user is giving command to whom? Computer to perform what? Particular operation. Okay. So what's the use of that command? So to do the particular operation, what data you are giving, in that data we are giving particular command or instruction. That is called as what? Instruction. Understand what do you mean by instruction? We are giving particular command to whom? To the computer to perform or complete the particular task on data. What data you are giving? In that data you are giving particular command. That is called as an what? Instruction. Okay. So one example I said, no, traffic police will give some instruction. Whether a particular person will obey or not, he needs to obey, isn't it? Likewise, we are giving instruction or command. That command needs to taken by whom? Microprocessor. That is machine level instruction. Why machine level instruction? Now we are studying about what? Internal components, isn't it? So that is a machine level instruction based on how the components need to execute or how the components needs to work. So basic set of machine level instructions we are giving to whom? Microprocessor. So that microprocessor will execute particular set of instruction, that is we are calling as an what? Instruction set. So understand what do you mean by instruction set? What's the use of microprocessor? Microprocessor is designed for the purpose of particular command we are giving, which kind of command or which kind of instruction. Machine level we are instructions we are giving to whom? Microprocessor. Particular microprocessor is designed to execute that kind of instruction is called as an what? Instruction set. Understand? So this instruction set has particular operations. So we are giving particular instruction. What are the types of instructions or what are the types of operations can done by particular instruction set? Understand? So listen, these are the operations carried by instruction set. First one is data transfer. What do you mean by data transfer? We can able to move the files from one place to another place. We can able to copy the file from memory device to one memory to another memory. That is called as data transfer. Flow of data from one place to another. Okay. Next one is arithmetic operations. What do you mean by arithmetic operations? Mathematical calculations. What are the mathematical calculations already you have studied? Arithmetic calculations, addition, subtraction, multiplication, division. That's the second operation. Next one is logical operation. Logical operation means logical diagram, either and that you will study in second chapter. Okay. And gate, NOR gate, XOR, based on lot of gates are there. Based on that, it will work. Ones and zeros. That is called as logical operations. Next, it will take care of control flow. What do you mean by control flow? Flow of control. That means water is flowing from upside to downside. Likewise, control flow. Flow of data from one place to another. That is called as control flow. Next one is input and output. What do you mean by input and output? So what data you are giving as an input. For that data after processing, you will get the output. Understand? So in this slide, this is the second characteristics of microprocessor. So what's the second characteristics? Instruction set. So in this instruction set, first you need to write what do you mean by instruction. What do you mean by instruction? So command you are giving to the computer to do particular task, that is called as an instruction. So a microprocessor is designed to execute the set of which kind of instruction? Machine level instruction, that is called as an which is set? Instruction set. So this instruction set carried out types of operations. Okay, many kinds of operations are there. What are they? Data transfer, arithmetic operation, logical operation, control flow and input out. Understand? Next one is word size. Okay, so what do you mean by word size means? So already I said we are giving the commands or instruction, isn't it? So the input, we are giving input by means of commands or instructions. The computer would take the input by means of a bits. First day itself said, I said the input we are giving, particular input is taken by the computer by using binary data or bits. What do you mean by bits? Either 1 or 0. Ones or 0. Okay, that is called as bit. Okay, so here you are giving many kinds of instructions. So in a single instruction, how many bits can be processed by a processor? That is called as word size. Okay, for example, I am giving instruction, go straight. How many words are there? 2. How many words are there? 2. Go straight. So single instruction. What instruction I am giving? Go straight. How many words are there? 2 words. Likewise, I am in a single instruction. How many bits? Go straight. How many words are there? First word? First go. In a word, how many characters are there? 2. G-O. Straight. S-T-R-A-I-G-H-T. 8 characters are there. Understood? By, for example, only for your understanding purpose only I am telling like that. Okay. Likewise, if we are giving one single instruction, in that instruction, the instruction means input. The input taken by the computer by means of bits. That means number, 1s and 0. So in a single instruction, how many bits can be processed by a processor? So microprocessor can able to process how many bits at for a single instruction. Understand? That is called word size. Understand? So this word size determine how much amount of RAM can be accessed by a microprocessor. Already you have studied about RAM. So how much capacity or how much amount of RAM or how much portion or the space, storage space of the RAM can be accessed by a microprocessor, based on which they can determine word size. Understand? So what's the third characteristics of microprocessor? Word size. What's the use of, what do you mean by word size? You are giving commands or instructions to a computer to do the particular task, isn't it? So for a task, you are giving instruction. For in a single instruction, so how the number of bytes for a single instruction, the number of bytes particular microprocessor can able to execute, that is called as what? Word size. Based on this word size only, the amount of RAM, that means this word size only determine how much capacity or how much storage can be accessed by a microprocessor, which memory? RAM. Understand? So this is one of the important 5-mark question. Okay. So which is important 5-mark question? Characteristics of microprocessor. How many characteristics you have studied? 3. What are they? Clock speed, instruction set and word size. Understand? Very, very important question. Now itself you understand and study. Okay. Next heading is data communication between CPU and memory. Okay. Data communication between CPU and memory. So, name itself having data communication. What do you mean by communication? For example, I am talking to you. So, I am communicating to you. That is interaction, isn't it? Likewise, data communication between CPU and memory. So, data communication between CPU and memory. Okay. So, data needs to communicate between two devices. What are the devices? CPU and memory. Okay. What do you mean by CPU? What's the expansion of CPU? Central Processing Unit. Okay. So, inside the Central Processing Unit, two kinds of registers are there. Okay. Inside the Central Processing Unit, how many registers are there? 2. What are they means? MDR and MAR. Okay, what do you mean by MDR? Memory data register. Okay, and what do you mean by MAR? Means memory address register. Understand? So inside the CPU, you have two addresses or two registers. So what's the name of the two registers? Memory data register and memory address register. So already we have studied about registers. For that only one best example I said. So for example, you are taking computer science group. So your class will be 11A. So 11A register, if I took 11A register mean, I need to saw what are the things available or what are the things are found inside this 11A register. What are the things? Your name, your roll number, your addresses, and the details of students of 11A, isn't it? So if I took the 11A register means I can able to read all the informations about 11A students. Likewise, what's the use of register? It will hold particular information. What do you mean by hold? Store particular information, isn't it? So inside the CPU you have two registers. What are they? Memory data register and memory address register. Okay, what's the use of MDR? Memory data. Name itself having data. Okay, memory data register means so it will keep all the records or it will keep all the store all the details of what are the data transfer between memory and the CPU. Okay, so MDR register contain the details about what are the things you are or what are the informations you are transferring between memory and the CPU. How many types of memory you have studied? Two types. What are they? RAM and primary memory and secondary memory. So in between this memory and CPU, what are the informations you are transferring? Okay, that all that information is stored in which register? Memory data register. Understand? Next thing, so two units you have studied, arithmetic unit and logic unit, isn't it? So this arithmetic and logic unit will have the address of all the memory. Okay, so if you are seeing inside the memory means each and everything are stored based on that address. Okay, so for example, you are a student. We are identifying you as a computer student means, so you how I need to identify you as a computer student? You have a particular group code, isn't it? Likewise, so in memory, many things you are stored inside the memory. So each and every data stored in the memory based on memory addresses. Okay, so all these addresses needs to be fetched. Fetched means get or taken. So all these memory addresses of this memory will be stored in where? Memory address register. Understand? So memory address register contain all the addresses of the memory. So these addresses will be handling by whom? Two units. Who are they? Arithmetic and logic unit. Understand? So in this slide you have studied about two important things. What are they? CPU has two important registers. What are they? Memory data register and memory address register. What's the use of MDR? It will contain or keep the data transfer informations transferred between the memory and the CPU. What's the use of memory address register? So each and everything you are stored in the memory, it will store based on addresses. So all that addresses will be keep track of by whom? Memory address register. So in the memory address register, these addresses are handling by two persons. Who are they? Arithmetic and logic unit. Understand? Yes. Next thing we are going to study about program counter, PC. Important 2-mark question. Okay, what do you mean by PC? What is defined PC or what is PC? Important 2-mark question. Understand? Listen. So this is one of the important special register. Okay, so among this register, this program counter is a special register. Okay, what's the use of this register means? This is the important line. So this register always keep the address of the next instruction to be executed. I'll explain. Now itself you study. This line is very, very important. Okay, that's the definition of this program counter always keep the address of the next instruction to be executed. Best example I am telling. For example, teacher asked to take attendance from roll number 1. So first roll number will say roll number 1. Then 2, 3. Listen, roll number after the roll number 1, the person who is saying roll number 1, after he says, then only roll number 2 will say. Isn't it? So, roll number 1, no. If I see, I have already I told my roll number, then only roll number 2 needs to say. So, roll number 1 holds the information or holds the roll number of 2. Understand? So, if roll number 1 over means only roll number 2 will say. So, what's the address of the next instruction here? Roll number 2. First instruction is roll number 1. Roll number completed. Roll number 1 completed. Sit. First attendance, he or she said. Then he is sitting. Then roll number 2 needs to say means what? After he or she says, after that only he needs to. So, he or she needs to take the informations after she know. After he or she tell the attendance means only I need to say. Understand? So here like that, what's the use of this program counter? So it will keep the address of the next instruction to be executed. Okay. So listen, this is the diagram. So this diagram, no need. This diagram is not available inside your book. So for your understanding purpose only, I am explaining this one. Okay. Listen. So consider this is the memory. Last slide itself I explained. So what are the things you are storing inside the memory? So memory is storing inside the memory based on memory addresses. So listen, this is, so what are the things you are storing in memory? All the things are stored in the form of bits. Isn't it? What do you mean by bits? 1 and 1s and 0. So for example, this is a location, first address, location 0. In the place of location 0, some message is stored in the form of bits 100, 101. Next, location 1, this is the memory address, location 1, next instruction. Likewise, lot of things are stored. What's the use of program counter means? So it will always keep the address of next instruction. For example, now this instruction, that means this place the instruction is executed. This place, the arrow mark they are given, no? This location particular instruction is executing. So it will keep the address of the for example in location 9 particular information is executing. Next instruction is this one, location 12. At the time of executing location 9, at the same time it will keep the address of location 10 also. Understand what I am telling? Location 9, in that place particular information is executing. At the same time it will keep the address of next instruction. Understand? That's the use of program counter. What's the use of program counter? It's one of the special register. Always keep the address of the next instruction to be executed. Understand? Next, we are going to see about bus. Bus means don't think about our transport bus. Okay. So, bus is nothing but a collection of wires. Okay. Normally, all the electric things we are connected by means of connection using what? Wire, isn't it? So, all the connections we are given using wire. So, in the name of already where we know all the things we are connected by means of wire. So, instead of we are saying wire, in computer we are saying as a bus. Understand? So, instead of we are saying as a wire, computer we are telling the name of a wire as a bus. Okay. So, listen. So, this is the definition of a bus. Sometimes they will ask for 2 mark question. Okay. What do you mean by bus? So, bus is a collection of wires. So, what's the use of this wire connection in computer? So, what's the use of wire connection? It will use to communicate between internal components of a computer. So, internal component, this is the motherboard. So, in the motherboard, how many components are there? RAM, ROM, likewise lot of chips are there. Inside this, all the things need to be communicated. So, how the communication happen? By connected by means of this bus. Okay. This is the diagram for various kinds of buses. This is one kind of bus. This is that means cables. That cables only we are calling as a what bus? This is a address bus. See, these cables are, have you seen? Is it visible? At this end, all these ports are connected by means of these cables or buses. Understand what do you mean by bus? Bus is a collection of wire. What's the use of this wire? Used to form communication between. So, these are the internal components of the computer. Understand? Yes. So, next thing is, so word in the RAM is there's the same size as a memory data register. Okay, already we have studied about memory data register, MDR, isn't it? So what do you mean by MDR? It will take care about the information transfer between CPU and the memory. So word in the RAM. What's the size? The size of RAM depends on which register? Memory data register. Okay. For example, for that only an example they have given. So if the processor is 8-bit processor means, for example, you are using microprocessor. In that microprocessor, the capacity is 8-bit. If the microprocessor capacity is 8-bit means the MDR and the word size in RAM also have 8 bits. That's the meaning. Okay. So you are using the microprocessor name Intel 8085. That's the name of the microprocessor. Okay. So this microprocessor capacity, that means 8-bit microprocessor. If the microprocessor is 8-bit means the word size stored in the RAM and MDR also have the same size as 8 bits. Understand? That's the definition they have given. Word in the RAM, the size of the MDR and the word size in RAM is same as the processor bits. Understand? Yes. There are two kinds of operations are there. What are they means? Read operation and write operation. So better for this one example I am telling. So you all know familiar about rewritable CD. So what's the difference between normal CDs and rewritable CDs? So listen. So in this slide there are two operations I said. What are the operations are done by MDR? Two. Read operation and write operation. For this only one best example I said rewritable CD. What's the use of normal CD and rewritable CD? So rewritable CD, you can able to copy the file and you can able to delete the file. Next time, so you can able to copy another one file. That is rewritable CD. Normal CD, once you have write the data, next whether you can able to delete the particular one? No. Why? That is called as read. Read only. Only you can able to copy or give an input some files. You can't able to edit or anything. But in rewritable CD, not like that. You can able to copy the files. You can able to edit. Next time you can able to store another file. That is called as write operation. Understand the difference between read operation and write operation? Yes, listen. So read operation transfers the data or bits from word to memory data register. Okay. So read operation transfer the information from where to where? Word to memory data register. Understand? So listen, the read operation transfers the data from, data means bits, that input what you are giving, from where to where? Word to MDR. But write operation just reverse to that. Okay. Read operation copying or doing the transfer from word to MDR. But write operation just reverse, transfers the data from where to where? MDR to word. Understand? Just opposite of that. Understand this one? Next we are going to study about types of microprocessor. Okay. So microprocessor can be classified as based on two important criteria. Okay. This microprocessor can be classified based on two important criteria. What are they means? First one, bit of data can be processed. What do you mean by bit? What do you mean by bit? Bit means nothing but volume or capacity. That means how much storage capacity it can able to process or how much capacity it can able to work. That is the bit of data can be processed. For example, your phone memory becomes 16 GB. So what's the capacity or what the width of the data can be able to store? Only 16 GB. But the 16 GB phone memory can able to store 18 GB data? No. Is it possible? No. So that is called as width. So what's this type of microprocessor? Microprocessor can be classified based on two criteria. What are they? Bit of the data and instruction set. First we are going to study about this the classification of microprocessor based on data width. Okay. So what do you mean by this width of the microprocessor mean? So it can able to, that means particular microprocessor can able to execute how much width of instructions. Okay. So depending on the width only, it can able to execute the particular instruction. For that only, one example already said, 16 GB memory means only 16 GB data can store. Likewise, based on the data width only, you can able to give the instruction. That means particular microprocessor can able to execute only based on data width. Okay, so based on this width, they are classified the microprocessor as this. Okay, 8-bit microprocessor, 16-bit microprocessor, 32-bit and 64-bit. Okay, so based on this width, they are classified for 8-bit, 16-bit, 32-bit and 64-bit microprocessor. Understand? So next thing is, so classification of microprocessor based instruction set. Okay, so here what do you mean by instruction set? Already you have studied. So particular microprocessor taken what we are giving input by means of a commands, isn't it, or instruction. So particular instruction, how much time or particular how much data are executed by the particular microprocessor is called instruction set. So here what we need to know means size of the instruction is very very important. Okay, so based on the size only we are going to classifying the microprocessor here. Okay, so what kind of instruction you are giving, so the size of the instruction, what size you are giving the particular instruction. Okay, that is the important consideration for determining instruction set. Okay, based on this instruction set they are classified into two types. What are they means? Reduced instruction set, that means RISC, RISC. Next thing, complex instruction set, CASC. Okay, two kinds. What are they? Reduced instruction set and complex instruction set. How they are classified? Based on the size of the instruction. How much size or how much volume you are giving for the particular microprocessor to execute. So there are some examples they are given. Examples of RISC are this one. You write it. Okay. Bino book also same examples only they are given. Pentium 4, Intel 6, AMD K6, K7. These are the examples of RISC. Then examples of CISC. This Intel 386. This and all name of the microprocessor. Okay. These are the name of the microprocessor they have used. Understand? Yes. This is the next heading. So till now we have studied about what? Microprocessor. Next, so up to that one part over. This chapter, computer organization, one part over. One part fully you have studied about microprocessor. Second part you are going to study about memory devices. Okay, memory devices. So what's the use of memory? So which is the memory part of human brain, isn't it? So what's the use of memory? You need to store all the informations in memory. Likewise, so what's the use of computer memory? So computer memory is the storage space for the computer. In that space only we are going to store the data and instructions, isn't it? So in your mobile phone, which is the memory part? Which is the memory part of your mobile phone? Two types of memories are there in your mobile phone. So what are they? Phone storage, that means internal storage. SD card, that is external storage, isn't it? Likewise, two kinds of memory devices are there in your phone also. Okay. So here also in memory devices, you can able to access two methods are there to access the particular data. So how many methods are there? Two methods. What are they means? Read or write. Okay. So already you have studied about read operation and write operation. For that only one example I said rewritable CD. So likewise, this memory devices are accessing methods. What do you mean by access? For example, net connection is there. Wi-Fi connection is there. You are accessing the net. What's the meaning of that one? You are getting particular connection. Likewise, there are two types of accessing methods are there. From where you need to access? Memory, already you have stored the data. For example, in your mobile phone, you have stored lot of video files are there. I need particular video file from your mobile phone, or I need to access particular video from your mobile phone. That is called as access. Okay. So I am going to access particular video from your mobile phone. Simply just I have opened the video in your mobile phone itself. That is called as read. Next thing, I am going to copying or transferring particular video from your mobile phone to my phone. That is called as a write. Understand? So what is the type of accessing methods are there? Two types. What are they? Read or write. Okay. So this read and write only they are giving us an two access method. Sequential access method and random access method. Okay. So this what are the two types of accessing methods are there? Based on this read and write operation, they are classified the access methods into two types. What are they? Sequential access method and random access method. Okay. Sequential means This is in orderly manner. It will access based on orderly manner. Understand? So listen, for example, so in your class, they asked you to sit based on your roll number wise. So if any person is coming inside your class, immediately particular person will call roll number 10. So 10th place particular roll number will stand, isn't it? So you are arranged based on roll number wise. That is a sequential order. Understand? So what do you mean by sequential access? So here sequential access means memory lot of data are there. So you are accessing the particular data in particular order from starting to end. That means from first place to last place. Understand what I mean by sequential access? You are going to access the data in the memory from or some sequential order wise from starting to end. So listen, random access means random. Name itself random. For example, same example I am telling. So you are asked to sit in your class as per your wish, not any roll number base, as per your wish. Maybe roll number 1 will sit in the first bench, roll number 2 will sit in the second bench, roll number 3 will sit in the middle bench. Whether there is any order wise? No, that is random. Understand? Likewise, random access in the memory means any byte of the memory can access any byte from any place, not any order wise. So what do you mean by bytes? Zeros and ones. Already we have studied. So already I show one diagram in program counter, no? So same diagram you think it. Any byte of the memory can access any byte from previous byte. That means not from any order wise or not based on any address base. Any byte of memory can be accessed maybe directly or through previous bytes. Okay, not any order wise. Understand? So in memory devices, two types of accessing methods you have studied. What are they? Sequential access and random access. Understand? So these memory devices are arranged based on one hierarchy. What do you mean by hierarchy? Some order. Okay, listen. So what's the first thing? Hard disk, main memory, cache memory. So which will have the higher capacity? Okay, which will have higher capacity. Listen. So larger capacity devices have slower access time. For example, particular device will have capacity 20 GB. Whether it is easy to access the files of 2 GB file, whether it is easy to access, or 20 GB file is easy to access, 2 GB file. Likewise, so if the capacity is higher, the access time will be very low and the cost also very low. Okay. If the capacity is low, you can able to access very fast and the cost becomes also very high. Understand? Based on this arrow mark you study. If the capacity is larger means access time is very slow and the cost will also lower. Likewise, if the capacity is very small, access time also very fast and cost becomes high. Understand? So if this is one of the very important question. So types of memory devices and memory hierarchy, very important 5-mark question. Okay. The ask for 5-mark question means you should draw this diagram. So in that memory hierarchy, first we are going to study about first type of a memory called random access memory, RAM. Already you have studied detailed about this RAM, isn't it? What do you mean by RAM? What do you mean by RAM? RAM is a random access memory. So already we have studied main memory is otherwise called as which memory? Random access memory, isn't it? Main memory is otherwise called as which memory? Random access memory. So this memory is available in the computer form of integrated circuit. What do you mean by integrated circuit means like a chip. Okay. So the RAM is available inside the computer like a chip. Okay. Simple chip. Okay. So what do you mean by whether this RAM is a permanent storage device or temporary storage device? Temporary storage device, isn't it? So what are the things we have stored in the RAM? Will be not a permanent, it will be a temporary storage device. So for example, so if you are opening the computer, so you are opening the lot of applications, you are seeing photos and lot of things. So while you are starting the computer and you are using that particular things, at that time you are using OS, lot of program. And what are the things, so photos or images or anything, videos. So what are things you are using? You are not storing anything, but you are simply viewing. So that is a temporary storage, isn't it? So all that kind of things are accessed by whom? So what are the things you are doing that and all accessed by whom? Are processing the information by whom? Microprocessor, isn't it? So that kind of things is stored in which memory? RAM, random access memory. Okay, understand what do you mean by random access memory? Main memory Sadhur is called as RAM. So here this RAM is made in the form of a what? Integrated circuit. So this the temporarily storage device, all the things are, what are the things you are storing temporarily? All the things are present inside the RAM. Okay. So this is important, one more question. A smallest unit of information stored in the memory is called as dash bit. Okay. What's a bit? 1 or 0. Okay. A smallest information, most smallest information stored in the memory we are calling as an what? Bit. Okay, so collection of 8 bit is called as an byte. Okay, what's the difference between bit and byte? For example, computer, C-O-M-P-U-T-E-R. C is a bit, computer is a byte. Understand? C is a bit, computer is a byte. The smallest unit of information storing inside the computer is called what? Bit. Okay, so the memory can be accessed the particular information total, that is called as what? Byte. That means a collection of 8 bit is called what? Byte. Understand? See. So this is the diagram of RAM. Okay, is it visible? So RAM is a volatile memory. What do you mean by volatile? Volatile means the information stored is not a permanent. Okay, what's the difference between permanent and temporary? Permanent means what are the data you are storing will be stored permanent. So anytime if you are C means also the data will be stored there only. Okay, that is called as permanent. But what are the things you are storing in RAM? One time if you are for example, if you are storing particular things in the RAM, after that after completion of your work, you are switch off the computer. Next time if you are switch on the computer, that things are not available in the RAM. Why? It is a temporary storage device, that is non-volatile memory. Understand the difference between volatile and non-volatile? Volatile means the things you are stored in the memory is not permanent, that is called as volatile. So that only I said. So if immediately the power, if you are working in the system, power when means, so whatever data you are storing in the RAM will not be stored, it will lost immediately. Okay. So this RAM you can able to read as well as write operations. So listen, this is the diagram for, this is a picture of a RAM. Have you seen it? So this RAM will be placed inside motherboard. Next diagram see. So this place we are keeping in this motherboard. I have kept 2. How many RAMs are there? 2 RAMs are there. Okay. In this slot we need to place the RAM. Understand? So next thing, there are types of RAM. So RAM is divided into 2 types. What are they means? DRAM and SRAM. Okay. How many types of RAMs are there? 2. What are they? DRAM and SRAM. DRAM means dynamic RAM. SRAM means static RAM. Okay. So how they differentiate between DRAM and SRAM means, so based on the capacity of holding data, that means storage of data. How much capacity they will hold the data. Based on that, they are classified into 2, DRAM and SRAM. How they are classified? Based on the holding of information. Okay, this DRAM needs to be refreshed frequently. What's the meaning of refreshing? Refreshing means once again needs to start. Like wait, that process needs to once again repeat. That is called a refresh. This DRAM needs to be refreshed frequently. Okay, but static means static. What's the meaning of static? Permanent. Like wait, static need not to be compared to this DRAM, SRAM, that's compared to this RAM, no need to be refreshed again and again. So compared to DRAM, this SRAM will work more faster. Okay, so this static RAM is more expensive than dynamic RAM. Sometimes they will ask for 2 more questions. Differentiate between DRAM and SRAM. What's the first point? DRAM is a common time of RAM. It will needs to refresh frequently, but SRAM need not to be refreshed frequently. The DRAM works very slower. The static RAM works faster. So SRAM is more expensive than dynamic RAM. Okay. So today up to this enough. So what are the portions I have taught? Please study thorough. So what are the things? Important question. Memory devices, very important question. Please study thorough. Thank you students. Thank you one and all.